Let's take it up a notch with this quadratic equation with denominators, which means we're going to again be dealing with an LCD and with restrictions. So remember, in these cases, you need to always make sure that your denominators are factorized so that you can find an LCD. So if we look at the first term, there's nothing we can do to that at this stage. But the second term has a very simple numerator, and our denominator is a quadratic trinomial, so we need to factorize it. Remember, we're looking for factors of 3 that can give us 4 through addition. So 3 times 1, the 3 and the 1 can give us 4. So we're going to have an x and a 3, an x and a 1. The signs in the brackets are the same, and they're both negative. Now, we need to start thinking ahead, otherwise we end up doing a whole extra step, and that can waste a lot of time in a test environment. So we see that here, having factorized this trinomial, we've got an x minus 3 bracket. Remember that as these two terms are standing underneath the fraction line, they are acting as if they're in a bracket. So this is a 3 minus x bracket. So how do we get that to become that? So remember, we need to multiply by -1 and multiply by -1 again, because -1 times -1 is 1. And if we multiply anything by 1, it doesn't change its value. So I'm going to multiply the 10 by negative, so it will become -10. And I'm going to multiply this bracket by negative, which means it's going to become x minus 3, which is great because then I've got the same as what I've got over there. This has no denominator, it's staying as it is. So once I've factorized my denominators, I'm then ready to work out my LCD and also to do my restriction. So it's handy sometimes just to put your LCD on the side. Looking at this fraction, I have a bracket of x minus 1. Looking at this fraction, I have a bracket of x minus 3. And then I also have an x minus 1, which is the same as that. So I already have a representation of that bracket. And then when I look here, I have already got the x minus 3 represented over there. So that is my entire denominator. Now I need to do my restrictions at the same time. So remember, anything in the denominator is not allowed to be equal to 0 because we can't divide by 0. So what x value would make this equal to 0? X is not allowed to be 1. And what x value would make that equal to 0? 3 minus 3. So x may also not be equal to 3. So carrying on now, I need to multiply each of these terms by my LCD. Well, when I multiply this term, and remember this is also acting as if it's in a bracket, by that, the x minus 1s would cancel, and I'd be left with what I already have on the top, and then also multiply by that bracket. Carrying into the next term, I write down what I already have there, minus 5. That's my denominator, and I'm multiplying it by the LCD. So in this case, both of the brackets will cancel, so that -5 won't be multiplied by anything. I have a -10. If I multiply this by the LCD, the x minus 3's will cancel, and I'll be left with x minus 1. And then I already have minus 1 here, and because it has no denominator, there's nothing to cancel with either of those two brackets, and so we have x minus 1, x minus 3. And we have wonderful bird accompaniment today to keep us going through this long quadratic equation. I now need to multiply out all the brackets that I have here. Luckily, I have eliminated the denominators, but now I need to eliminate the brackets so that I can gather like terms. So using FOIL, and we're going to start combining inners and outers now to save time. So x times x is x squared. My outers are giving me minus 3x. Minus 2x is going to give me minus 5x. My lasts are going to give me positive 6. Write down what you have. Multiplying this into the bracket, I'm going to get negative 10x and positive 10. And then I'm going to really start combining lots of steps together now, because we've been through all the basics. So I'm going to do FOIL on this, and at the same time I'm going to multiply by the negative outside. So x times x is x squared, times by the negative is negative x squared. Now I'm going to do my outers and inners in the same step. So I've got negative 3x minus x is negative 4x, times by the negative 1 is positive 4x. My lasts give me positive 3 times by the negative 1 gives me negative 3. So if we don't start combining things like that, and it does take concentration not to make a careless mistake, we can actually eliminate quite a lot of writing. So now I want to get all my terms onto the same side, because it is a quadratic equation. And I'm going to also do this in one step. So I'm going to say I've got x squared. This is going to come across the equal sign, so it will become plus x squared. X squared plus x squared is 2x squared. I have minus 5x plus 10x gives me 5x, minus 4x gives me 1x. Here I have 6 minus 5, which is 1. This is coming across. 1 minus 10 is negative 9. Negative 9 plus 3 is negative 6. And the other side is equal to 0. I know that I need to do that whenever it's a quadratic equation. So looking now, seeing as I have a coefficient of 2 here, I'm going to use the cross method. So 2 times 1 is my only option for factors of 2. And then I need factors of 6. So I could be doing 3 times 2 or 2 times 3. And try and think ahead beforehand, because remember we're going to multiply down the arms. Try and think which would be the best option. We're trying to end up with a coefficient of 1. So if I put the 3 there and the 2 there, 2 times 2 is 4, 3 times 1 is 3, and can 4 and 3 give me 1? Yes, they can if I subtract them. So now I can read across for my two brackets, and I have 2x and 3, 1x and 2 equals 0. And this is telling me that the signs in the brackets are different and the biggest combination is positive. So my inners are giving me 3, my outers are giving me 4, so that's the bigger combination, and the other one has to be negative. And now we're also going to start going straight from here to our answer for x, instead of writing all sorts of steps in between. So either that has to be equal to 0 or that has to be equal to 0. So if I say 2x minus 3 equals 0, then it means I'm going to be dealing with a linear equation. So let's go straight to the answer. If I had 2x minus 3 equals 0, I would take the 3 to the other side, and then I would divide by 2. So therefore, x is going to be equal to 3 going to the other side will become positive, and dividing by that 2 will put it over 2. Or for this to be equal to 0, that's very easy. X would have to be equal to negative 2. But now, before I can underline those answers and say that they are acceptable, I need to go back to my restrictions, and this is what a lot of people forget to do at the end. My restrictions said that x may not be equal to 1 or to 3. Are either of those here? No, they're not. So therefore, I can accept my two answers. And we will go on to a more challenging example in episode 5. So look out for that too.